Alright, so I think we've had just about enough of our boring old static walls and floors. Let's make something move. I'm going to scroll up to the top here, and I'm going to create an add a crate function. Control-Shift-1, and there we go. We're adding a crate. I apologize for the background noise. I'm doing laundry. So basically, adding a moving object is almost exactly the same as adding those static objects. The only difference is our density will now be a number greater than 0. So we want to add a falling block to the world. We'll set it to, I don't know, let's have it go to 250 minus 30 so that it sort of off-screen and falls into our world. And, well, alright. I think that should be easy enough. So we'll create our falling crate def, which is a B2 polygon def. We will set as box, and let's have it say 50 pixels by 50 pixels. And remember, set as box wants the half width and half height. So we'll create it as 25 and 25. Let's set our friction to, I don't know. I'm just making up numbers here. Probably not very bouncy because it's going to be a wooden crate. Density, I don't know the density of wood. I could probably look it up, but given that wood, along with ducks and very small rocks, float, let's make it less than 1, so 0.7. We're going to create our, excuse me, there we go, falling body def, which is a B2 body def. We're going to set the position to 250 minus 30, and just to make things a little interesting, let's set the angle to say 30 degrees. Unfortunately, Flash likes its rotation in degrees. Box2D likes its rotation in radians. To convert degrees to radians, you multiply by pi over 180. All right, I think we're set. Let's have our falling crate equal our world. So this falling crate will be our body. Sorry, should specify that. Our world will create the body using the falling body def. We will create a shape using our falling crate def, and I probably should have called that falling crate shape def. I'm sorry. And we will now call set mass from shapes. Sorry. This time it's actually needed because we really do care about the center of mass of this object. That should be about it. Let's just run this, see if there are any compile errors, see what I forgot. Wow, okay, everything compiled perfectly. Clearly that has nothing to do with my figuring out all the code in advance. This is like those cooking shows where sort of they've got everything already magically working out. So let's see, now that we actually have a crate that's falling in the world, let's see if we can at least display some interesting information about it. I think probably what we want to do is let's create a enter frame event that gives us the X and Y value of this falling crate. That would be kind of fun. So the first thing I probably need to do is actually take this falling crate and make it a member variable instead of just this local variable. I happen to be one of those people that likes taking all the member variables and putting a underscore in front of it. And Flash Develop has a very neat little trick. If you hit Control-Shift-1 on a local variable declaration, it has a promote to class member option. By doing that, I've now taken this falling crate, v2 body. It's become a private variable or private member of my Hello Box World movie. That's kind of neat because it means I can now report on this falling crate body within, say, my enter frame event. With me so far? All right, excellent. I'm going to add an event listener, and this will be an event. Here's another neat little thing. If I hit Control-Shift-1 again on this event class, Flash Develop has now gone and created a flash.events.event import statement. Very nice. And I want enter frame, and we'll, I don't know, new frame event. Here's something else pretty cool. I can hit Control-Shift-1 on new frame event, and I get an option to generate the event handler. Look at that. Got a private function called new frame event. It's already passing E as an argument. And now I will add our trace statement. Falling crate dot get position dot x dot y. There you go. Now we're going to run it. And let's see what sort of fun output we get. Well, all right. Our falling crate is at 6.25 and minus 0.75. That actually makes sense because remember that we are reporting this in meters. We're reporting this in Box2D numbers. If I wanted this in pixels, I'd probably want to multiply these values by ratio. But the problem that you've probably noticed is that our falling crate isn't actually falling. We have a magical levitating crate. And why is that? It's because we forgot to do one important thing that I will show you in the next lesson.